Hi class, welcome to this new video where together we will compute the values, the eigenvalues and eigenvector of a square matrix. From the previous video, we saw how to determine the eigenvalues and eigenvectors of a certain square matrix. The first step is, once having this equation, you know that the solution of this equation is the eigenvector x for special value of lambda. From here, you can have this equation, and once you have this equation, you can solve for the determinant of ax minus lambda I equal to 0, having x non-zero. Once having this, you can therefore determine the value of lambda, which are the root of the characteristic equation from here. And once you have the value of lambda, you can now have the value of the eigenvector x. Now, let's have a look on an example. Example 1. Find the eigenvalue and the eigenvector of matrix 1, 3, 2, minus 4. So how will you do that? You have to solve for determinant of a minus lambda I equals to 0 to have the value of lambda. So determinant of a minus lambda I, which equals to the polynomial of lambda, right? I have 1 minus lambda, 3, 2, minus 4, minus lambda, which is equals to 1 minus lambda times minus 4 minus lambda minus 6, right? Which is equals to lambda square plus 3 lambda minus 10, right? If you multiply this, you see you have minus 4 minus lambda plus 4 lambda plus lambda square minus 6 minus 4, which is minus 10. Then if you combine the like terms together, you have this, and this can be easily written as lambda minus 2 lambda plus 5 equals to 0. So solving for lambda here, I have two values of lambda. Lambda 1 equals to minus 2 and lambda 2 equals to 5. Now let's find the eigenvectors of each value of lambda. Now for lambda 1 equals to minus 2, I have to solve the equation lambda minus lambda I v equals to 0, right? So which gives that I have that 1 minus lambda 3, 2, minus 4 minus lambda, right? v1, v2 equals to 0. So writing this in an echelon form, right, I will have that lambda is minus 2. So I have 1. Lambda is 2, sorry. Lambda 1 is 2. As you can see here, so it's 2. So I have 1 minus 2, which is minus 1, 2, 3, and I have minus 6. Now, what do we have here? I realize that if I do the row echelon of, Gauss reduction, I have that R2 equals to, right, R2 plus 3 R1, which will give me minus 1, 2, 0, 0. And see that if now I divide the first row by minus 1, so I will have that, I will have 1 minus 2, 0, 0, and I have it here. Now, I realize that my x1, so if I have two variables here is x1 and here is x2. So x1 is fixed and x2 is free. So if I have that x2 equals to t, meaning from the first row, I have that x1 minus 2t equals to 0, giving that x1 equals to 2t. Now, if I want to find my vector, I have v, right, which is x1, x2, right? x1 is 2t and x2 is t, so I have t, 2, 1. So I can see that my first eigenvector here will be t, 2, 1, t belonging to R, and t different from 0. Now, if I'm looking for the second value, the second eigenvector for lambda equals to 2, so I have lambda equals to 5, lambda 2 equals to 5. So solving the equation a minus lambda I v equals to 0, I have that 1, yes, minus 5. Yeah, lambda minus 5, I have that 1 plus 5, and I have 3, and I have 2, and I have minus 4 plus 5, right, times x1, x2 equals to 0, 0, right? So this will give me 6, 2, 3, 1. Okay, so, and I'll have here x1, x2 equals to 0, 0. So if I do the row echelon here, right? Or let's say I divide the first row by 2. If I do the row echelon here, I will have 6, 2, 3, 1, 0, 0. So which will give, if I divide the first row by 2, I will have 3, 1, 3, 1, 0, 0. And then if I do now that the second row equals to second row minus the first row, I will have 3, 1, 0, 0, 0, 0. And then I'll have that my first variable x1 is fixed, and then x2 is free. Okay, because I can also write this like dividing the first row by 3, I have 1 over 3, 0, 0. Okay, which makes more sense when I say that my first variable is free and the second one is fixed, and the second variable x2 is free. So with this, I can have that x2 equals to t. So I have that x1 plus 1/3 of t equals to 0, which leads to x1 equals to 1/3 of t. So if I want my vector v, x1, x2, I have that x1 is 1/3 of t and x2 is t. So I have t 1 minus 1/3 and 1, right? Okay, so and from here I have my second vector v, which is t minus 1/3 1, with t scalar of r and t different from 0. So someone else can write this multiplying the vector by 3. Someone else can have that s equals to v equals to s minus 1, 3, with s belonging to r and s different from 0. So yeah, we now at the end of this video, and we hope that you understood step by step how we should determine the eigenvalues and the eigenvector of any square matrix of your choice. In the next video, we will solve more complex example like 3 times 3 matrices. Thank you very much. See you soon. Bye.